Welcome to this webinar session on VESDA application and performance-based designs. As buildings have become increasingly more complex, in many cases there are fewer one-size-fits-all solutions prescribed in codes and standards. In a simplified definition, performance-based design departs from prescriptive requirements of codes and standards as key stakeholders, for example, owners, architects, authorities having jurisdiction involved in a project, establish design goals, for example, life safety, and use those goals to arrive at a performance-driven solution. Performance-based design offers a creative alternative approach to following prescriptive code requirements. Our codes and standards such as NFPA, the International Building Code, the International Fire Engineering Guidelines, etc., recognize alternative approaches may be necessary and provide an established process for deviations from prescriptive measures. NFPA 101, for instance, devotes an entire chapter, and the Society of Fire Protection Engineers, SFPE, published the SFPE Engineering Guide to Performance-Based Fire Protection, each outlining the process by which a design team would go through to develop performance-driven solutions. The process includes concepts like defining goals, defining measurable performance criteria to compare to the outcomes, developing design fire scenarios, evaluating the design with iterations as required, and document the design. The goal of our presentation is not necessarily intended to instruct attendees on how to conduct performance-based designs, but instead introduce examples and demonstrate how VESDA, air sampling smoke detection systems, can be applied to satisfy design goals and how Xtralis can assist in that effort. The starting point which ultimately sets direction of any performance-based design approach is, of course, to set goals and objectives. As can be appreciated, there are a number of possible drivers, but generally goals tend to fall into one or more of the following categories: ensure occupant safety, minimize impact to building or operational cost, maximizing asset protection, ensuring business continuity, and bridge gaps in prescriptive codes. Designing complex buildings requires sophisticated processes, tools, and solutions. Technology plays an important role. VESDA is one such asset that designers can leverage to meet performance-based goals and objectives. Attributes such as quantitative and predictable detection performance, wide sensitivity range, very early warning and incipient detection capability, multiple programmable alarm threshold settings, flexibility in sampling pipe network design. When designing and installing with accessibility in mind, VESDA can overcome challenges with respect to access in tough locations. Each of these attributes makes it possible to apply smoke detection, where in some applications detection would otherwise be difficult or impossible. In the next few slides, we'll introduce and review a few examples of projects where VESDA and Xtralis were deployed in performance-based designs. Atria represent unique challenges for fire detection. There is no one-size-fits-all solution for atria design. Consideration must be given to ventilation schemes, makeup, air introduction, smoke dilution, temperature gradient, stratification, and the special needs for early warning for safe egress in high occupancy buildings where atria designs are generally employed. Our first case study presents an example of challenges associated with atria fire detection for the Gaylord Texan Resort and Convention Center, which comprises an atrium with a height of 64 meters. This is a truly difficult environment for detecting smoke. Large volumetric space and constant supply of fresh air introduces smoke dilution. Fluctuations in outside temperatures produce massive internal temperature differentials. Codes and standards provide little to no guidance on applying smoke detection to address such challenges. The requirements, goals, and unique characteristics of the structure and environment required a performance-based approach and technologies capable of delivering performance expectations. VESDA was investigated and ultimately applied. Here's how Xtralis participated in the performance-based design project. We worked with stakeholders in clearly understanding the project goals, developing design fires for assessing both smoke detection and extraction. We then conducted computational fluid dynamic modeling of stratified smoke movement and fire detection, factoring in different fire scenarios ranging from 500 kilowatts to 5 megawatts. With the information at hand, Xtralis optimized the VESDA design, considering ceiling and vertical options based on these simulations. To accurately test the fire scenarios, Xtralis designed a smoke detection test methodology suitable to simulate fire and assess early warning detection systems in large open spaces. With a smoke test apparatus centered to the center of the atrium, fire tests were conducted by local fire contractors and witnessed by fire consultants. The total heat generated from the radiant heaters was equivalent to a fast growth fire of 230 kilowatts. Effective detection was delivered well ahead of the minimum performance criteria of 5 megawatts within 5 minutes, responding in just over 3 minutes to a 230 kilowatt fire. VESDA's performance exceeded stakeholder goals, further enhancing life safety, providing a solution in absence of clear direction in prescriptive codes. As discussed earlier, sometimes the goal of a performance-based design is to overcome particular challenges that may limit use or add burden to construction or maintenance cost. In this particular case study, this 26-story office building in Queensland, Australia, underwent a change of ownership and usage. The new owners decided to maximize available floor space, changing the layout of each floor. The preferred layout impacted egress distance by 7 meters, exceeding the 40-meter code allowance. The owners therefore had a decision to make: accept a less efficient layout affecting the entire building, or use a performance-based design alternative to improve egress. Early warning smoke detection was therefore the goal, intended to compensate for the extended egress distance. It was unclear to the design team if the spot-type detectors originally installed throughout the building would be sufficient in providing the early warning needed to meet the objective. Xtralis was consulted and asked to participate in the performance-based design process. We worked in conjunction with the stakeholders, developing the various fire scenarios and design fires to be used in the assessment. We then conducted computational fluid dynamic modeling on agreed fire scenarios to predict detection performance between VESDA and spot-type smoke detectors. Modeling predicted VESDA would provide at least 7 seconds earlier response time than spot-type detectors. Validation through in-situ tests were carried out, where a total of 5 tests were conducted to demonstrate performance of both technologies across agreed upon fire scenarios. Validation testing was witnessed by all stakeholders and proved the model predictions to be correct. This ultimately led to the owner following through with their floor plan usage goals, allowing them greater flexibility and efficient use of total available floor area, while meeting egress life safety requirements of code. Our third case study examines an application at Zamuna Future Park, a multi-use, high-occupancy shopping mall in Bangladesh. There are a total of 5 atriums located throughout the structure, measuring 40 meters to the peak, with each atria forming part of the egress path. Mechanical ventilation systems were provided, but there was no local fire codes that addressed the unique challenges presented for the structure. Ultimately, NFPA 90B was applied, and detection of a 5 megawatt fast-growing fire within 5 minutes was required. The typical of the region was frequent and extended power outages, which meant natural ventilation schemes would have to be assessed as well, and early detection would be required to adequately evacuate the occupants ahead of smoke descent times throughout the atria. Xtralis supported the performance-based design process by working with stakeholders to develop fire scenarios and design fires, conducting modeling to assess extraction performance of both mechanical and natural ventilation schemes, and by designing VESDA to achieve stakeholders' goal for the project. Validation through in-situ tests confirmed VESDA exceeded model predictions, providing as much as 3 minutes of advanced extraction through natural ventilation schemes. This ultimately led to reduction of 8 mechanical extraction fans, thus saving initial cost and energy cost, and providing sufficient confidence that egress requirements could be met. As buildings grow in complexity, performance-based design is changing the way owners can design their buildings. Performance-based design offers design flexibility and the opportunity to rethink how buildings are and can be constructed. When prescriptive requirements do not seemingly allow or permit a certain design, performance-based design is an option to consider, especially for unique, complex buildings. Vesta is well suited and proven performer in performance-based designs, offering quantitative and predictable performance. Xtralis has extensive experience in the performance-based design process and can assist in a variety of ways. We've helped customers across industry segments ranging from automotive, aviation, metro, to clean rooms, correction facilities, substations, and retail spaces to achieve their performance-based design goals.